Good day. I am Mum Bing. Welcome to my general mathematics class.
So we are still at week 8 of general mathematics, and this is the last topic for this week and the last topic for the first quarter. So these are still the content standards and the performance standards, and also the MELCs. And the last topic for this week is solving real-life problems involving logarithmic functions, equations, and inequalities. Okay, let us recall. So as the saying goes, a person who does not remember where he came from will never reach his destination. So because of that, here are some exercises to refresh your mind. So you are going to determine whether each of the given below is a logarithmic function, a logarithmic equation, a logarithmic inequality, or neither of the three. Enjoy working while recalling your previous lesson regarding logarithms and have fun. So let's have the first one. The first one is the function of g of x is equal to 2 log of x. And that is a logarithmic function. Okay, next one. We have y is equal to the log of 2x minus 1 with base 4. And this one is a logarithmic function. And then the next one, we have x log of 2x with base 8 is equal to negative log of 3x minus 5. And that is a logarithmic equation. The next one, we have log of 4x minus 1 is greater than 0. And it is a logarithmic inequality because it has an inequality symbol or sign. And the last one, we have g of x is equal to 2x minus 7. And this one, it is neither of the three. Okay? Logarithmic functions, just like the exponential function, can be used in solving real-life problems or situations. So word problems involving logarithmic functions, equations, and inequalities generally involve solving and evaluating exponential form. Exponential and logarithm cannot be separated from each other. If the given problem is in logarithmic form, it is necessary to transform them to exponential and solve them for the unknown value which will satisfy the original equation or function. So here are some of the application of the exponential, the Richter scale, the pH scale, and the magnitude. So since they are inverses, so exponential and logarithm cannot be separated. Okay? So they are connected with each other. Example 1. The COVID-19 pandemic, according to news, is spreading rapidly, transferring from human to human. It is a kind of virus that affects the human respiratory system, and it is commonly associated with cough, pneumonia, SARS or yung severe acute respiratory syndrome, and other respiratory-related infections. Let us assume that the virus has an initial population of 10,000 and grows to 25,000 after 50 minutes. Assume that its growth follows an exponential model. F of t is equal to a multiplied by e raised to kt, representing the number of viruses after t minutes. The e is used to model because the virus continuously grows over time. So let us find a and k and use the model to determine the number of viruses after 6 hours. Let's have the solution. So given f of 0 is equal to 10,000, so that is the initial population of the virus. So thus f of 0 is equal to a multiplied by e raised to k0, where a is 10,000. Solve for k, you have f of 50, which is 50 minutes, is equal to 25,000. So 25,000 is equal to 10,000 multiplied by e raised to k 50. So by dividing 25,000 by 10,000, so we have 5 over 2 is equal to e raised to k 50. So by taking the natural logarithm, since we have e here, so we have 50 k is equal to the natural log of 5 over 2. So solving for k, we have k is equal to natural log of 5 over 2 divided by 50. So the value of k is now k is equal to 0.0183 2. Therefore, A is 10,000 and K is 0.01832, and also the exponential model is f of t is equal to 10,000 multiplied by e raised to 0.01832 t, and this exponential model will be used in solving for letter B. So letter B, if 6 hours or 360 minutes, so we have f of 360 is equal to 10,000 multiplied by e raised to 0.01832 multiplied by 360, we have 7,315,752. Therefore, there are 7,315,752 number of viruses after 6 hours. So by using the formula or the exponential model, we can solve for the problem or what is being asked in the problem. Let's have another example. Example 2. So under certain circumstances, a virus spreads according to the equation P of t is equal to 1 over 1 plus 15 e raised to negative 0.3 t, where P of t is the proportion of the population of the virus spread at 3 days. How long will it take the virus to spread at 75% of the population? So this is now the mathematical model or the formula that we are going to use to find how long will the virus spread at 75%. So let's have the solution. So the given is P of t is equal to 0.75, that is 75%. So we have 0.75 is equal to 1 over 1 plus 15 multiplied by e raised to negative 0.3 t. So by multiplying both sides of the equation by this, we got 0.75 plus 11.25 multiplied by e raised to negative 0.3t is equal to 1. Then, we combine 0.75 and 1, so we got 11.25 multiplied by e raised to negative 0.3t is equal to 1 minus 0.75. Simplify further, we have 11.25 multiplied by e raised to negative 0.3t is equal to 0.25. So, divide both sides by 11.25. Divide natin siya ng 11.25. And then, this one also. So, ito. Then, what we have now is e raised to negative 0.3t is equal to 0.25 over 11.25. And this part is equal to 1 over 45. Then, solve for the value of t by dividing both sides of the equation by 0.3, negative 0.3. Since 1 over 0.45 is 45 raised to negative 1, therefore we have negative 45 divided by negative 0.3. So we have now t is equal to 12.69. So you can solve this using your calculator. So direkta sa calculator, you can find the value of t. So therefore, it will take approximately 13 days for the virus to spread to 75% of the population. So there are problems that we can use logarithmic function and also the exponential functions since they are connected with each other. So we can use both of them in solving for the problem. So these are some of the application of the logarithmic functions. Okay, that would be all for this week. Thank you for watching and God bless.